The next parameter that we are going to consider is return loss. So we have analyzed the situation like we have a source and we have an antenna and some power is transmitted to the antenna, and because of the impedance mismatch some part of the power is getting reflected back. So in this condition the return loss is defined as the difference between incident or the feed power and the reflected power. So both the powers are considered in dB. Return loss in dB is incident power in dB minus reflected power in dB. So if it is considered in watt, the return loss in dB will be 10 log 10 of pi by PR. So let's see some cases. I'm considering the feed power is around 40 dBm, and because of the impedance mismatch around 10 dBm of power is getting reflected back. In this case return loss can be calculated as 40 dBm minus 10 dBm. It will be equal to 30 dB. So let's assume another case where the reflected power is getting reduced. That means that antenna is more matched to this feed cable. Here the input power is 40 dBm and the reflected power is 5 dBm. So in that case return loss will be 35 dB. That means that when the reflected power is getting reduced, return loss is getting increased. That means high value of the return loss is always preferred. That means the low reflection and the return loss will be always positive, because we know that incident power is always greater than the reflected power. So it will always be positive. Next, we can consider a complete reflection case. Here we can see that incident power is 40 dBm and we are considering all the power is getting reflected back. So in this case, return loss will be 40 dBm minus 40 dBm. That will be the 0 dB condition. So if the return loss is 0 dB, it means that complete reflection. So now let's see what is the acceptable limits for return loss. We know that about 10% of power is reflected back is the acceptable conditions most of the industries. So I'm going to consider the case where only 10% of the power is getting reflected back. So here I'm considering around 1 into 10 to the power of milliwatt is the feed power that corresponds to 40 dBm, and because of the impedance mismatch around 10% of power is getting reflected back, that is 0.1 into 10 to the power of 4 of milliwatt is getting reflected, which corresponds to the dBm power of 30. And when we subtract incident minus reflected, we will get a return loss of 10 dB. So the 10% of power reflection corresponds to a return loss of 10 dB. So return loss of 10 dB is the acceptable limits for our condition. So if we are designing an antenna, we have to make sure that the return loss is more than 10 dB. So that is all about return loss. I hope you get some idea about the return loss. And our next video will be on the S11. Thank you. If you find any of our videos useful, kindly support by liking, commenting, sharing, and subscribing. Thank you.